Hey everybody, welcome to topic number 3. In this video, let's review the exponent rules and your radical expression. So your exponent rules, so there are several exponent rules that I did not list over here. I'm just listing the main ones. So the first one I want to talk about is a product rule. Product rule says for any real number a raised into the n power times the same base raised into a different exponent. So when the base are the same and the base are multiplying, we will add the exponents. Okay. So for example, I do want to show you this real quick. Let me click on it real quick. Yep. For example, 1x plus 1x. We know 1x plus 1x is 2x, right? So what's the difference between x plus x versus x times x? Well, x times x, multiplication between anything is only one term. So x times x is one term. So the rules for multiplication of variable is different than combining like terms, right? Plus and here, combining two terms. So you get 2x. So 1x times 1x, when the base are the same and base are multiplying, we will simply add the exponent. So that's how we actually get 1x squared. We got to add the exponent. So the difference between the two is the number of terms the expression has. So these exponent rules only applies for, actually only applies for one term. Okay, multiple terms problems. Those are combining terms, and so it's different between combining term versus multiplying, which is just one term. All right. So let me quickly explain why do we add the exponent. So for example, if I have an x to the third times x squared. X to the third means x times itself 3 times, right? Times x squared means x times itself 2 times. So when it comes to multiplying variable, we add the exponent because now if you count, I got 5x's being multiplied together. That's why it's going to be x to the 5th power. All right. So here the example. When it comes to multiplying, we multiply the coefficient and we add the exponent for the variable. So negative 3x to the third times 4x to the 5th. Negative 3 times 4 is negative 12. X to the third times x to the 5th. Okay, based on the same and based on multiplying, we add the exponent, so that will be 8. All right, quotient rule is where we will subtract the exponents. Okay, so when the base are the same and the base are dividing, we will subtract the exponent. It will always be the top exponent subtracts the bottom one. Okay. So when the bases are the same and dividing, then we will subtract the exponents. Okay, and the reason why for subtracting the exponent is because we are basically canceled out the same exact factors, top and bottom. So using this one, for example, I got a to the 4 on the top. That means 4 different a's being multiplied together over a to the 7 in the bottom. That's 7 a's being multiplied together. So when you see all these A's, top and bottom, you can cancel them out because they're all one term over one term. So now you end up with 3 of them left in the denominator. So a lot of times, I will simply just say, we got 4A on top, 7A in the bottom. When they canceled out, there should only be how many A's left? There should be only what? 3 A's left in the denominator. All right, 5 and 35 can be reduced by 5. That would be 1 and 7. So I got a 7 down here, 1 on the top. Okay, and the A already canceled out for the top. So that will be 1 over 7A to the third power. All right, negative exponents. When the exponent is negative, okay, when the base has a negative exponent, what we will do is flip the base to the other side of the fraction and write the exponent as positive value. So this A to the negative n power, technically that base A is on the numerator. So since it has a negative exponent, we will flip it to the other side and write the exponent as positive. Later on the semester in other topic, we will actually redefine this definition here. So technically, every time when you flip the base to the other side of the fraction, you got to change the signs on the exponent. So if I flip it back, if I take this a to the n power, flip it back to the top, then my exponent got to change the sign back to the negative sign. So this thing is going back and forth. Okay, it's going both ways. If a base has negative exponent, you flip it to the other side, become positive, right? If it's positive on the bottom, if you flip it back to the numerator, then that base will end up with a negative exponent. It goes back and forth. All right, so for right now, I'm just gonna flip all the bases that has negative exponent to the other side. So 8 is to the first power, right? The t is to the -2 power. So 8 will remain on the numerator. The t will flip to the other side and write the exponent positive. So that's 8 over t squared. There are three different versions of what we so-called the power rule. The third one is actually pretty much the same as the second one. Power rule C. I'll write it down here just as a reminder. All right, power rule says if the base is raising to a higher power on the outside the parenthesis, we will multiply the exponents together. So again, inside the parenthesis is one term, right? You got a parenthesis and another exponent on the outside, so we will actually multiply the exponent. It's almost very similar to the distributive property, okay? So now if you look at power rule B, I got two different bases inside the parenthesis, A times B. Okay, so the outer exponent will multiply all the exponents, okay, that are inside the parenthesis. So that's how we get a to the n power times b to the n power. So this example, this base 2 is to the first power, x to the -3 power. So it's almost like I'm bringing them to the outside the parenthesis first, but multiply the exponents. So the base 2, okay, if I multiply the exponent, 1 times 2 is 2. So my base 2 is now to the second power. All right, 2 times -3, that will give me -6. So the x coming out of the parenthesis will be x to the -6 power. Since the x has a negative exponent, the x will flip to the other side of the fraction. That become x to the +6 power. 2 to the second power remain on top. 2 squared is 4. All right, so this example here has three different bases, right? Or three different factors inside the parentheses. So once again, all these are what? All these are just one term in the parentheses. So my outer exponent will multiply all the exponents that are inside the parentheses. So the 2 is to the first power. 1 times 2 is 2. -3 times 2, x to the -6. 4 times 2, y to the 8 power. So only x has a negative exponent, so that will flip to the other side, become x to the +6. 2 squared remain on top is 4. Y to the 8 still on the top. Did not get flipped because they're all over 1, right? All these 2x and y I wrote is actually over 1. So only the x will flip to the bottom. Power rule C just a fraction version of power rule B. So for any real number A and B, whole thing raised into an outer exponent on the outside. Then this outer exponent on the outside will multiply all the exponent in the inside. So that will give me a to the n power over b to the n power. All right. A lot of time I ask students this question. A plus b. What is a plus b whole thing squared equal to? And a lot of times students will say, oh, that's a squared plus b squared. And that is actually very wrong because we are trying to apply the power rule, okay, for this particular problem. But if you look closely on the two example I have up here, inside the parenthesis is only one term. So the power rule you can only apply power rule when there's one term inside the parenthesis. So we cannot simply say this is actually a squared plus b squared. Okay, that's one of the reason why, because here inside the parenthesis, this is technically two different terms. Okay, the power rule can only apply if there's only one term inside the parenthesis. So exactly what is a plus b whole thing squared? Well, for right now, since the exponent 2 is sitting on top of the a plus b, you can look at it as a plus b times a plus b. So we will talk further about this in the next topic. All right. Oh, sorry. Power rule C is down here. Sorry, I wrote it up here also. So for this example, right, outer exponent -2 will multiply the exponent for the x and the y. So that will give, so once the space x and y come out of the parenthesis, will be x to the -4, right? 2 times -2. 3 times -2 is y to the -6. Since both x and y has negative exponents, so they will both flip to the other side of the fraction. So the x to the -4 will come to the bottom, become x to the +4. y to the negative 6 will go to the top, become y to the positive 6. Okay. All right, let's talk about radicals real quick. Radicals are basically your roots. Square root, cube root, fourth root, those are called radicals. What's inside the radical is called the radicand. Okay. So as you can recall, square root of 16 is equal to 4. But the answer is y. Why is 4? Well, a lot of students say, well, because 4 times 4 equal to 16. That is true, but that doesn't explain why square root of 16 equal to 4. So I'm going to write 16 a different way. I'm not going to write the 16 inside the square root as a 4 times 4 because I'm going to write it differently. 4 times 4, though, is actually the same thing as 4 squared, right? Let me erase that. We're good. Square root of 16 is the same thing as square root of 4 squared. So why square root of 16 equal to 4 is because squares and square roots are opposite operation. So they tend to cancel each other out. So the only thing you have left is simply just a 4. Okay. So why square root of 16 equal to 4? Because squares and square roots are opposite operation. So they cancel each other. Out. There you go. That's the reason why. So cube and cube roots are opposite operation, so they can cancel each other out. All right. So here's another exponent rule called a rational exponent. The word rational in algebra also means fractions. Okay, so this is basically saying I have a fraction exponent. So when the base a raised into a fraction exponent, okay, the denominator determines the roots. The numerator tells you what the base is raising to inside the radical. Okay, rational exponent converts into a radical expression. Denominator is the root. Numerator tells you what the base is raising to. So for this example, x to the 2/3 power, right? Denominator is a root. So right away, I have a cube root. The numerator tells me my base x is raising to that second power. There you go. Vice versa, this x is to the first power, right? Denominator is the root. So my base x, denominator is the roots. The denominator of the fraction exponent is the root, which is fourth root. The numerator is what the base is raising to inside the parenthesis, inside the radical. So fourth root of x is actually x to the 1/4 power. All right, so here's a good example. Okay, this is a rational exponent written in a quotient rule form, right? Because I got x on top, x on the bottom, right? So I can actually subtract the exponent. So apply the quotient rule for exponent. So that means we're gonna subtract the exponent. So always the top exponent subtracts the bottom. So I'm gonna use this opportunity to review subtraction of fractions real quick. So add and subtract fraction, we always find the LCD first. So LCD between 3 and 4 is 12. So 3 becomes a new 12 times by 4, numerator times 4, that's 8. Denominator 4 becomes a new LCD 12 times by 3, numerator times 3, so that'll be 8 minus 3, which will give me 5/12. All right, and of course you can do this in the calculator. That's not a problem. I just want to review a little bit as sometimes I gotta to review, refresh everyone's memory. So this x to the 2/3 minus 1/4 power becomes x to the 5/12 power. All right. So number 2, sorry, it's kind of close. Number 2 says convert the correct answer number 1 into a radical expression. So if I convert into a radical, right? Denominator is 12. So that determines the roots. So I have a 12 roots, right? Numerator is what the base is raised into inside the radical. So that's 12 root of x to the 5th power. All right, negative rational exponent rules, just like the negative exponent rule. When your exponent is negative, we will flip it to the other side and write the exponent as positive. So the same thing. All right, simplify the following radical expression. So we will do more of these simplifying radical expression in a different topic, but I do want to introduce it here, showing student how to simplifying radical. There are two ways to simplifying radicals, because if you put square root of 18 inside the calculator, it's going to give you some sort of weird long decimal. So those are, it's considered as an irrational number. So those decimals is really, we can't really work with them. But we can actually simplify the radical. So there are two ways. One of the ways is actually break these numbers inside the square root or cube root down by using prime factorization or prime numbers. So I'm gonna put my 18 inside this upside down division, and on the outside, I'm gonna actually use prime numbers. So the popular prime numbers, okay, the popular prime numbers that I normally use. So this is a discussion question again. Popular prime number, by the way, one is not a prime number. Prime numbers only have one set of factor, one in itself. The number one is not a prime number. One times one is not really fit into that definition. But the first prime number is two, right? Not our number, prime numbers. Three. One times one is three, just one times three, right? Four is not a prime number. Five is because one times five. Five is only one times five. Six, seven. Seven is only one times seven. Eight, nine. Nine is not a prime number because nine is one times nine and three times three. So that's not a prime. Prime number only has one set of factors, one in itself. The next one is 11. So these are the popular ones. So you can use any one that can go into this 18. I can use two, I can use three. So I'm gonna use two first. Two go into 18 nine times. All right, I'm gonna continue. Nine can be used prime number three, go into nine three times. Three is a prime number, only three can go into three one time. So when the bottom number is a one, that's when you stop. So basically, 18 is made out of two times three times three. So earlier we mentioned square root of 16 is equal to 4 because square and square root cancel each other out. That is true. On the other hand, it's also saying in order to go outside of a square root, you need two of the same number being multiplied to go outside as one of them. This is another way of looking at it. So here, right, I'm going to write it down here. This 18 is now 2 times 3 squared, right? 3 times 3 squared. So square and square root cancel out. This 3 will come outside. These two got to stay in. So ideally, in order to go outside of a square root, you need two of the same number. So these two 3 will go outside of the square root as 1 3. There's only 1 2, so that stays inside. So your answer, 3 times square root of 2. All right, let's try again with the 120. So I can use 2, I can use 3, I can use 5. I'm gonna use 2 first. That's 60. Using 3 next, which is 20. I'm gonna use 2 again, which is 10. 2 again, which give me 5, and 5 go into 5 one time, right? 5 is a prime number. So in order to go outside as a square root, I'm looking for two of the same numbers. So these two twos will go outside as 1. And there is nobody else can go outside. So the 3, the 2, the 5 stays inside. When they stay inside, they're technically being multiplied. Because what I'm not writing down is 2 squared times 3, blah, blah. There's 3 2's here. 3 2's here. 2 squared. These two is 2 squared times 1 2 times 1 3 times 1 5. So square and square root cancels out. This 2 goes outside. Everybody else stays in, being multiplied. So my answer, 2 times square root of 2 times 3 is 6 times 5 is 30. So that's my answer. So that's my simplified answer for square root of 120. All right, so let's take a look at homework. Most of these questions, question 1, 2, 3, and 4, 5 are all from definitions. So please use what is written on the lecture handout to enter for your answers. Question number 6 is just like the one we just did earlier. Apply the quotient rule. So I want you to subtract the exponent and tell me this is x to the whatever that fraction come out to be for the exponent, and then convert this into a radical for me, okay? So in this lecture video, we review quite a few of these exponent rules, okay? And we also review a little bit on how to simplifying the radical. Okay, thank you so much for watching.